Okay, hello and welcome again to the second webinar in a series of webinars on using technology in business statistics class. This webinar is an Excel data analysis tutorial, so it takes you into how to use Excel's features to perform statistical analysis that you're asked to perform in your BA 215 class. This tutorial, this webinar series will help students to overcome being bogged down with a lot of the technical things that they have, a technical um, process, technicalities that they have to perform as they do their statistical analysis, and instead focus on the explanations and the understanding of the material that's presented in the course. Now, an introduction. My name is Denise Williams. I am one of the mathematics tutors that is associated with Grantham's Math Center as part of the Student Learning Center. I am a statistics educator. I have been teaching statistics at the college level for more than 10 years. And so, based on my experience, as well as the feedback that we have gotten from the students at Grantham, I feel that the webinar that we are putting on today and in the future will help many students to succeed in the BA 215 class. Now, since we've gotten through with the introductions, we can start with the material. Now, data analysis in Excel is very, very useful. It's very simple to do as long as you know what you're doing, of course. And there are at least two ways that we can talk about how to perform statistical analysis or data analysis in Excel. The first one is using Excel formulas and functions, Excel's formulas and functions. And we talked a little bit about this in the last webinar. These are formulas that are built into Excel that you click on the text box, click on the function box and just type the formula in directly. We also talked last webinar about the analysis tool pack, which is something that Excel has made available as an add-in that you can use to perform more complicated, simple to complicated analysis. And there's nothing that you have to do, no formula that you have to type in. You just click on a button. We also talked last time about Stat Plus. There are many students like myself that are not running a PC or not working with a PC. Instead, we are working with Macs. And while you cannot perform data analysis, you cannot use the analysis tool pack in Excel for Mac. There is workarounds. For example, there is something called Stat Plus, which is software that can be downloaded from the website that is listed on the slide. This is a free download that allows you to perform the same functions that you would perform if you were able to use the data analysis tool pack. It's a free download. Again, it's a free download, so you don't have to pay anything for it. Now, if there's any other computer user, any other uh, version besides PCs or Macs that are out there, please let us know. Contact the Math Center, and we can help you find a workaround, something that you can use to perform your statistical analysis by computer. Now, again, the computer that I am going to be using today, or the software that I'm going to be using today, is a Excel 2013 version, the Excel 2013 version. So last webinar, we talked about how to install the analysis tool pack for the Excel 2013 version, but we also gave you links to different versions of Excel. So if you have an earlier version of Excel and you are trying to install the analysis tool pack, please see the previous webinars, the previous YouTube videos that were linked as well. Okay, now once your analysis toolpack is installed, this is what we're going to be using today. We are going to go ahead and start with today's lesson. So today we're focusing on correlation analysis. Correlation analysis. Now, what is correlation analysis? Correlation analysis um, consists of graphs, formulas, and lines. Graphs, formulas, and lines. Uh, Now, correlation analysis is used to explain the relationship, or at least to show the relationship between two quantitative variables. It's used to show the relationship between two quantitative variables. Now, what we do in statistics is that we have a graph, and then the graph is supported by numbers or some type of data. So in correlation analysis, it's the same. We have something called a scatter diagram, which you see three of on your screen. There are three scatter diagrams where we plot uh, the variables against each other and see if there's a pattern in the data set. Now you'll see in each of the graphs that there's a line going through the data, and we're going to talk about what that means later. That's very significant. In addition, on the first graph, in the first graph to the left, the blue graph, you'll see that there is a formula that says y hat is equal to 42.3 plus 0.49x. Now, this is something that is called the least squares regression line, and we're going to talk about how to get this as well. Now, in the graph on the right, the top right, you'll see at the very top of the graph, it says correlation is equal to 0.801. This is also a significant part of correlation analysis. This is also referred to as R, and we'll talk about how to get this as well. Okay. Now, what is correlation analysis? We've talked before, just briefly, that correlation analysis consists of scatter diagrams, linear correlation coefficient, also called R, and the least squares regression line, which is the line that's drawn through the center of the data. Now we're going to talk about these in detail, one by one. Okay, so we'll start with the scatter diagram, which is the first part of performing a correlation analysis. Now, why do I want to draw why do I want to draw a scatter diagram? In statistics, of course, which you'll see eventually, we love pretty pictures. We love pretty pictures. Statistics is useful for all branches of science. It's useful business for businesses, it's useful for education, it's useful for everything. Now, not everyone has a quantitative background. What I mean by that is not everyone loves to see numbers. So we have to draw the pretty picture to go with the number. And that's what the scatter diagram is. It helps to display, it helps to display or helps display the relationship between two quantitative variables that are measured on the same individual. So we're looking at two measures on one individual, and we put these on one graph. Now, on the graph, what we have to focus on are the explanatory or predictor variable, and what this is a variable that's used to predict the response variable. It's normally displayed on the horizontal or the x-axis. In addition, we have to find the response variable, and this is the variable whose value can be explained by the predictor variable, and this is displayed on the y-axis. Now, what are we talking about, the explanatory or the response variable? Um, Briefly, because this webinar is not to replace what you are learning in class. It's not replacing your book, it's just an add-on. So we're not going to talk in detail about what these things mean. They're explained in your book. But an example of explanatory and response variables, or the differences we'll talk about, one briefly, is that uh, if I want to see whether or not the SAT scores, this is a hot topic lately, SAT scores affect GPAs in college, uh, I can determine, I can use my students' SAT score in high school to predict their GPAs in university while they're in the university. Now, the SAT score would come first. It's what I'm using to predict. Whatever comes first in the time series, whatever comes first would be referred to as the explanatory or predictor variable. So my SAT scores would be my predictor variable. Now, what am I trying to predict? I'm trying to predict a GPA. And so the GPA would be the response variable. If I were to draw a scatter diagram, the GPA would be on my Y axis, my vertical axis, and my SAT score would be on my X, my horizontal axis. Now, let's look at another example. This example is not in your book. It's not in your book, but it's very similar to things that you're asked to do in your book. Now, a scatter diagram, you're asked to draw a scatter diagram for a golf pro who wants to learn the relationship between the club head speed of a golf club and the distance that the ball will travel. So there are two variables here that are noted for each individual, for each time. So the first variable is a club head speed. The second variable is the distance in yards. Now, there are 8 observations, 8 individuals, and we're asked to draw these individuals on a scatter diagram. Before we can draw the scatter diagram, though, we have to decide which variable is the explanatory variable and which variable is the response variable. We want to know what goes on the x-axis and what goes on the y-axis. So how do we determine that? Now, because the pro wants to use club head speed to predict the distance the ball travels, we have determined that the club head speed, the first variable, is going to be the explanatory variable, and that's going to be listed along the horizontal axis. Now, the distance that the ball travels, this is what we are trying to predict, and that then is referred to as the response variable and is listed along the vertical or the y-axis. Now, once we have determined what is the predictor and what is the response variable, then we can go ahead and draw the scatter diagram. So we're going to take this data that we have here and we're going to transfer it over to our Excel spreadsheet. I've already done that here. So we have an Excel spreadsheet. And in the first column, column A, I have listed my predictor variable. I've listed my predictor variable. So the 8 values for the club head speed are listed in column A. In column B, I'm listing my response variable. So the 8 corresponding values for the distance the ball travels is listed in the B column. Now, what we want to do is we want to draw a scatter diagram. There are many ways to do that, but we're going to focus on how to do it for Excel 2013 using the charts that are built in here. So in Excel 2013, you'll see that there are tabs at the top of the screen. I'm currently at my home screen here, the home tab. But there's also the file tab, the insert, page layout, formulas, data, review, and view. Now we're going to go to the insert tab. Now under insert, there are also subtabs or subsets, sub boxes. And in the 1, 2, 3, fourth box, it's called recommended charts. And you'll see here that there is insert scatter, XY, or bubble chart. Now I'm going to click on this chart because this is the one I want. And we're just going to click on the first chart. Something I forgot to do. Highlight my data. I'm going to highlight my data, and then I'm going to click on the chart. And this is my data set. Now, what do I notice here? One, it's kind of small. But besides that, I'm going to make it bigger, and I'm going to show you how to make it bigger. Extend it here. Now, some things that I want to change. First, I want to show my labels for my X and Y axis, and I also need to change the title of this chart. So how do I do this? Again, in Excel 2013, there's a little plus sign to the right of the chart. I'm going to click on this plus sign, and here there are checks. There are boxes that can be checked, and the boxes represent the data. I'm sorry, represent what kind of options I can use or for this chart, for this scatter diagram. So I'm going to click on the axis titles, and I'm going to change my axis title. So for the x-axis, I'm going to click on this, and I'm going to type. I'm going to highlight it and type in my x-axis values. Remember that the x-axis values are from the first column. So this is club head speed in miles per hour. Along my y-axis, I have distance in yards. Now what I'm going to do for this one, because I don't want to type upside down or sideways, I'm going to click on the box, and then go up to the function box here, and I'm going to type in the name of my variable, distance in yards, and it puts it in for me. Now my chart title has to change because this is not correct, and I'm going to put the club head speed versus distance. This is the name of my chart. Now, what else can I do with this? If I go to design, now here on the top, there are also subtabs, I think they're called. And I'm going to go to my design tab, and I want to move the chart because it's kind of small here and I want you to be able to see it well. So click on move chart and say that I want it to be a new sheet that's in here. I'm going to rename the sheet. Let's see if I can. So I renamed the sheet, and here is my graph. Now, if I want, I can copy it and then paste it into your homework. So open up Microsoft Word or whatever software program you're using, click it in there and paste it. So here is my scatter plot for club head speed versus distance. Now I've done it already in Keynote, in Keynote, which is what I'm using. And here's the same graph that we just saw in Keynote. Now, to go back through the steps. First, step one, you're going to put the explanatory variable. This is not mandatory, but to save headaches, to make sure that you don't have any headaches, it is a good practice to put the X variable first in the first column, the A column, and then you put the response variable in the B column. You can have the headings if you want, like I had, club head speed in the first column and distance in the second column, or not. It's up to you. You then go to insert charts and then you select the scatter diagram and follow the instructions that are up here on the screen. It's very, very simple to draw the scatter plot, the scatter diagram. Now, the next thing that we're going to talk about after we have drawn the scatter diagram is to say, what does it mean? It's a very pretty graph. What does it mean? Now, based on what you have seen in your statistics classes and in your statistics book, when you draw a scatter diagram, what we are looking for, especially in this basic statistics class, is a linear relationship. We're looking for some kind of pattern that exists between the data. And in this particular data set, we do see a pattern. What conclusion then can we draw? It would appear from this graph that the data, the club head speed, as that gets bigger, that the distance that the ball will travel also increases. So if I want my ball when I play golf, if I want my ball, and I don't play golf, to travel a very long distance, then I would use a very large club head. If I wanted to travel a small distance, then maybe I would use a small club head. This is what my scatter diagram shows me. Now, this is a very lovely picture to look at, and it gets even lovelier when we have more than just 8 data sets. We have more than just 8 points. But uh, what is the use of this if we don't have some numbers to back it up, which is what we're going to talk about next. We're going to talk about something called the linear correlation coefficient and how to calculate this in Excel. Now, as a review, the linear correlation coefficient is also denoted by the variable r. It's spoken about in your book. R can take on any value between -1 and +1 inclusive. It can take on any value between -1 and +1 inclusive. A number, any R value that's close to -1 means that the relationship between the two data points, the two variables, are related in a negative manner. That means as one goes up, the other one goes down. If the R is close to 0, it implies that there is no linear relationship between the two variables. And if the R is close to +1, it implies that there is a positive linear relationship between the variables. As one increases, the other increases. The linear correlation coefficient is used in conjunction with the scatter diagram. For a good statistician, for anyone in this class, you cannot just show a pretty picture. You have to give some number to back it up, and that's what this linear correlation coefficient is. It's a number to back it up. Something else that's very important to remember about this, because we'll talk about it in our analysis, is that the linear correlation coefficient, R, measures the strength of the linear relationship between two quantitative variables. It does not tell us if there is a relationship that's not linear. It just tells us how strong the linear relationship is. And so maybe we will talk a little bit more about that, or you'll see something that alludes to that in your assignment. Now, how do we perform correlation, or how do we find the correlation coefficient? We have the step-by-step technology process here. First, we're going to, well, there's 2 steps. We're going to talk about the one using the data analysis toolpath. Make sure that it's activated, and then when you select data analysis, you're going to highlight correlation, select OK. Make sure that the data is highlighted, and voila, it will give us the correlation. It will give us a table. Now, let's go ahead and do a problem. So let's go back to my first data set. We had club head speed and distance in yards, and I want to calculate the correlation using the data analysis. So again, I'm going to go to the top of my screen, and I'm going to find my data tab. I click on data, and then I go over to the right where it says analysis, and then I'm going to click on data analysis. It opens up my data analysis tool pack, and under analysis tools, there are a list of many. We talked last week about descriptive statistics. This week, we're going to talk about correlation. We click on OK for correlation. Where it says input range, make sure that this is highlighted, and you can highlight the data that's here. Make sure that if you are selecting, in addition to the numbers, you're also selecting the column heading. make sure that you select labels in first row. If you where you want your output should also be uh, specified. If you want it on the same table, in the same workbook, in the same worksheet, you should make sure that this is specified here. So I want mine on the same worksheet. I'm going to click on this and I'm going to click on D2, column D2, which is where I want my data. And click OK. Okay. Now, what is this table giving me? What is this table actually showing me? This is telling me the relationship between club head speed and club head speed. That's what this column, this cell is telling me. The relationship between distance and distance is what this is telling me. This is what we're focusing on. What this tells me is the relationship between the distance and the club head speed. So my R value or the correlation for this is this number. My correlation is 0.938695838. Now what do I use this for? This number is very, very useful. It tells me that the relationship between my data here, the relationship between my data here is very, very close to a straight line. It shows that it's almost a perfect linear relationship. As one thing gets bigger, the other thing gets bigger. It's almost perfect. It's a very, very good number. So my correlation, again, is 0.938695838. Now let's go ahead and do this example. Do another example. Now, now that we know how to do the scatter plot and the correlation coefficient, let's go ahead and do that for another example that's found not in your textbook. Now here, a doctor wants to determine whether there's a relationship between a male's age and his HDL, or so-called good cholesterol. He randomly selects 17 of his patients and determines their HDL cholesterol, and of course records their age. So there's 17 only male patients of this doctor, and he has the age and HDL cholesterol listed there. Now, the first thing that we're asked to do is we're asked to draw a scatter diagram. Now, in the scatter diagram, we need to know what is the explanatory variable and what is the predictive variable. Here, it tells us that we're going to treat age as an explanatory variable. And what's the response variable? I'm sorry. And the explanatory variable, age, that means that that's going to go in the x-axis. What is also important is that means that age is going to be listed listed in my first column because it's explanatory. So explanatory goes first, response goes second. Now, this data I have already put in here. So I have my age versus HDL cholesterol, and I have my, oops, I'm missing a data point. Or I have one too many data points here. Okay, so I want to draw the scatter diagram and see, based on the scatter diagram, if there appears to be a relationship between age and HDL cholesterol. Remember, age is my explanatory variable, my predictive variable, and so I put that in my first column. Remember that HDL cholesterol is my response variable, and so I put that in my second column. Now I'm going to highlight my data first before I start. Highlight my data, go to my Insert tab, go to Charts, and select my scatter. And here is my scatter plot. Now, remember, I want to change this a little bit so that it looks prettier. And I am going to change my title. So I have age versus HDL. Here I have age. And here I have HDL cholesterol. Okay. And then I'm going to take this and I'm going to put it in a new chart. So here's my new chart. Now, what else am I going to do with this one? All right, now I'm also going to try and find my correlation coefficient. Let's look at the graph though first and see if we see anything. Does it look like there seems to be some type of pattern? Now, the data does not really look like it's following some kind of straight line pattern. Here, it's curving, it's curving. Maybe if I were you, if I were me, I would say that the data appears positively related. Perhaps it's positively related, but the relationship is not very strong. Now, since our graph does not help us out very much, what we have to do again is calculate the correlation coefficient. So I'm going to go back to my tab, age versus HDL, and I am going to go to my data analysis, correlation, click OK, and I make sure that I highlight my data. Labels in first row. Output range, again, put it here. Okay. Let's see, I did something wrong. Oh yes, I did. Okay, my output range here. Okay. Again, please ignore the ones. We're focusing on this. Now this number is negative 0.16366437317, and this number represents my correlation, or the strength of the linear relationship between age and HDL cholesterol. Now this number, along with the graph that we have here, so this number, along with the graph that we have here, shows that there is absolutely, or it looks to have absolutely no relationship to one another. The number is very close to zero, very close to zero, and in fact it's negative. So this kind of shows that if there were a relationship, it would be negative. The older someone gets, the older someone gets, the lower their cholesterol levels. But because this number is actually closer to zero than it is to -1, it implies that there is no relationship, at least no linear relationship between age and HDL cholesterol level. Let's go back to our problem. So we kind of did B and C already. But for A, we're asked to draw the scatter diagram, treating age as the explanatory variable, which means that we put it in the X column, and HDL cholesterol we put in the Y column. We are asked to compute the linear correlation coefficient, which we found to be negative 0. A small number. And then we're asked to comment on the type of relationship. Again, this implies that there is no linear relationship between the two variables. Now let's go back. Let's go again to another problem. Here it's a little bit more complicated, and it is a four-part problem. The first part is pretty simple. The researchers wondered whether the size of a person's brain was related to the individual's mental capacity. So, as children, sometimes, uh, some children can be cruel. In the playground, you would make fun of people would be made fun of for having big heads, and then myself being one of them. And then I'd go home and tell my mother or my father that all the kids said I had a big head. And then the parents would say to comfort the child that big heads just meant they had bigger brains and so they are smarter than everyone else. Now, is this true? People with big heads are smarter, or people with big brains actually smarter than the average individual, or smarter than people that have smaller brains? Is this true? Now, what the researchers wanted to do is to find out whether or not this really is true. And so they selected a sample of psychology students who had SAT scores higher than 1,350. This is on the scale from a few years ago, where the highest score was 1,600. And then they took their IQ scores. Now, this is the important part. They took their IQ scores. Now, they took the IQ scores of these students and compared them with their MRI scans. And the MRI scans gave them a count. The count then would use to determine the size of an individual's brain. So the higher the count, the bigger the brain. Now, what we're asked to do for A is to draw a scatter diagram treating MRI count as an explanatory variable and the IQ as the response variable. So explanatory means it will be in the first column and IQ will be in the second column. B, we're asked to compute the linear correlation coefficient. So we're going to do those two things first. Let's go to our Excel. So I already have my data listed here, MRI versus IQ, MRI versus IQ. And notice that we have a gender column here for females and males, but we're not going to pay attention to this right now. We're just going to focus on our MRIs and our IQ. So I'm going to highlight the data. I have 20 data points, 20 data points. And I'm going to click on Insert on the top of the screen and my scatter. And here I have my IQ versus MRI. And I move it into a new. So we have our graph. And what does it kind of look like to you? Does it look like there's a relationship between the two of them? To me, it kind of sort of looks like there's a relationship. I'm not really sure. And because I'm not sure, the next thing I'm going to do is what they ask us to do, which is to calculate the correlation coefficient. It looks like there might be some kind of positive relationship, but I'm not sure. So I'll go back to my original data and I will go to data analysis. Under my data tab, data analysis, correlation. Okay, my data a little bit more than what it was in the last one, so I'm going to highlight more. And I'm going to have my place here in E2. And okay. Data. Oh. That's great. So there are some, it's reading my data as text. So let's see if I can. Okay, let's see if that fixed the problem. So again, go to data, data analysis. Let's see if this works. Okay. And I want only B and C column and everything else. Okay. Okay, good. So it appears that there is some relationship, linear relationship between MRI count and IQ. So again, what we are focusing on here is the number that is in the bottom middle. This 0.548028141. This number is not very close to 0. It's not very close to 1. What it implies is that there's a very, very weak positive linear relationship between brain size and IQ, or MRI count and IQ. Very weak. So it might be true that the bigger someone's brain is, the smarter they are. But it's not a very strong relationship. It's not very strong at all. So we'd have to do a little bit more analysis. Now, before we said that we're going to ignore this column on gender. We're going to ignore this column on gender. So now I don't want to ignore it anymore. Let's go back to the keynote presentation and see what they ask us to do. So for C and D, we're going to redo the scatter diagram, but we're going to do the scatter diagram where we take into consideration the different genders. So what we're going to do is use a different plotting symbol. Now, the Excel app, the Excel tool does it for us, and that what it will do is change colors. So if I want to have the series for females only, it will use one color, and then when I plot males on the same graph, it will use a different color. So let's show how to do this. Go back to the Excel. Let's go back to Excel. So let's look at my data again. I have MRI count and IQ. I'm gonna erase this for you, or move it at least. I just didn't want to be up here at the top. Okay, so I have MRI count and IQ, and then I have the different genders, and I'm going to draw both of them on the same graph, but now I'm going to take gender into consideration. So I'm going to go to, first I'm going to highlight the data here, but I'm only going to highlight the data for the females, and I'm going to go to the insert, the scatter plot, and here is my chart. Now I can change the titles, again, the axis title, the chart titles, and so on. And I'm going to do that. So I have MR account versus IQ, but I'm going to add in something to make it different from the graph that we did before. And I'm going to make sure that you know that we're doing it per gender, by gender. So MRI count is on the x-axis. Remember, it's the first one. And then IQ is on my y-axis. Now, I'm going to click to make sure that the okay. I'm going to click on my chart, right click. So I'm going to right click on my chart, right click on my chart, and I'm going to go down to where it says select data, select data. Oh, I could also do that here. So I right click on my chart and I right click on my chart and I can go down to where it says select data, or I can go to the top where it says select data and just click on that. Now, what I want to do is I'm going to rename the first series. So this series that I have just graphed, these are for the females only. So I'm going to rename the series to female, for females, and I'm going to click OK. And so the data that's shown here, I know are for the females. Now I'm going to add another series, and I'm going to do the males. And I'm going to type in males as a series name. And in the X values, I'm going to click on X values box, click on the X values box, and then I'm going to highlight for the males only the MRI counts. So from this value all the way down. Then I'm going to click on the Y values, series Y values. And for the males only, I'm going to click on the Y value and pull that down. And then I click OK. Click OK. And here's my graph. Now, something I want here, because I know what these colors stand for. I know that the females are blue and the males are orange, but um, anyone else who's looking at my graph from the outside wouldn't know that. So what I'm going to do is I'm going to add a legend here. I'm going to add the legend. So I'm going to click on the plus sign, go to chart elements, and add legend. There are more options if you want to change the size, change the location. Um, you can click on that, but I don't need any of that. Now I'm going to move this to a new worksheet. And so here's my worksheet. And so I have MRI count versus IQ, but by gender. So based on this, I can see from a glance that highest IQ, the highest IQ belongs to a male, the lowest IQ belongs to a female, and this means nothing. The sample size was way too small. There's only 20 students, and they were limited. They're coming from one school. So this does not really mean anything. It does not mean that men are smarter than women. It does not mean really that brain size and IQ are related because of the size of the sample. But it's a nice start to our analysis. A nice starting point. Okay, so this is what we have. Mm, Now, finally, we'll go back to our slide. Finally, we're going to talk about something called the least squares regression line. The least squares regression line. Recall that in our first, when we're talking about, in our first slide on this, in this particular webinar, we showed a picture of a scatter diagram with a line going through it and the correlation at the top. Now the correlation, we talked about how to find that. We talked about what the scattered, how to create the scattered plot, scatter diagram. And now we're going to talk about how to get this line. This is very, very simple to do. Now, using the data that we have already, let's go back to the most elementary one, the club's head speed and the distance in yards. Now, the golf pro wants to find a line that goes through the center of the points. And why does he want to do this? Why do you want to find that line? That line is called a predictor line. So if in the future you have, for example, with this problem that we're working with, say in the future we have a club head speed of 104 miles per hour. This is not in our data set. We have one that is 104 miles per hour. Now, if you look through the numbers, there's no 104 there. But I want to predict how far the ball will travel if I have one that's 104. Now, what I can do is I can draw a line through the center of the data that I already have and use that line to predict wherever 104 is in the x-axis, what is the corresponding value in the y-axis, and that would be my predictor line. So how do I draw that in Excel? Again, make sure that you have your analysis tool pack in in installed and activated. You're going to put the explanatory variables in column A and the response variable in column B. You're going to use data analysis and highlight regression. And what this is going to do is actually give you the formula, for it. To draw the line is a lot even simpler than this. So let's go ahead and do that. So we go back to our Excel spreadsheet. And let's first go here to what we're trying to do, because I didn't do this before this webinar. Data analysis, what we said, data analysis, and then we're going to go to regression. Click OK. My Y's are here. My X's, make sure I click on the X box and drag. I have labels. I want my output to be here, D8, and I'm going to click OK. Now this is a lot of information, and what it really does, it's a lot of information. But the only thing that you need to know here are these numbers. The negative 5.79 and 3.1666. Now this is not spoken of a lot in your book, but it is very, very important. If you continue to do statistics, you'll need to know this. And this information, this is the intercept, this is the slope. To see how to use it in a formula, please see your book or your instructor. Now this is a lot of information with one button, and most of this information right now you don't need. The only thing that you need to focus on are these numbers right here. Now, another way to do this, and in fact an easier way to do this and to draw the line at the same time, is to go to the scatter plot that we have drawn. So let's go back over to our scatter diagram. Remember that we drew this earlier. Now here in the scatter diagram, we have everything almost that we need. We had calculated the correlation. Now what I want to do is to draw the line that goes straight through the center of the points. So I'm going to go to the plus sign, and here at the bottom there's something called the trend line, and I'm going to click on this trend line. Now if I go to trend line, it draws a line through the center of the points, and this is my least squares regression line. I can click on the little arrow, it gives me more options. Go to the more options, and at the bottom it asks if you want to display the equation on chart, and this I do want. So here's my equation, and I want it actually a little bit bigger. Make it any bigger. Hmm. Maybe no. Okay, so here's my equation. And these are actually the same numbers that we came up with here. So my 3.1661 and my negative 55.7966, these numbers are here. 3.1661 and negative 55.797. These are the numbers here. Now this is the equation of this line. And this line is called the least squares regression line. If I wanted to know what 100 and what the speed would be if my club head, I'm sorry, what the distance would be if my club head speed was 104, I would go to 104 on my x-axis, and then I'd find 104 on the line. And whatever the y value is here on this line would be my predicted value. Or I could plug in 104 into this equation and solve for y, and that would give me my distance in yards. So let's do that again for another, just to make sure that you got it. Let's do this again for another data set. So we did age versus HDL scatter. And I want to see, even though we saw that there's absolutely no relationship, but let's draw the line anyway. There's no relationship, but let's draw the line anyway. So we have the trend line, and I'm going to display the equation. And I'm gonna make it bigger. So here's my equation, here's my line, and from based on the line and the R value that we had gotten earlier, you can see that see, let me just get the R value back here. Well, I'll work on that. But so we see that the okay, sorry. So we see that the line has a negative slope, and so that implies that the R value was a negative number, but it's not a very steep slope, so it implies that there's really no, or just looking at this, it looks like a gunshot, that there's no real relationship between the variables. But if there were a relationship, we would use this equation to predict future values. We'll try it again for MRI versus IQ. Again, this one had a weak positive linear relationship, and so we expect a line that has a positive slope. So let's add the line, and we can display the equation. We can make this bigger. Let's make it all bigger. Okay. I could be making these all bigger. Anyways, so yeah, so we have MRI versus IQ, and here's our trend line, and here is our equation. Remember, this means 3 times 10 to the negative fifth power, so it's almost zero. Negative, I'm sorry, 0.000003 plus 109.89. So this is our scatter plot. This is our least squares regression line. And earlier we found our correlation, which was 0.548. Okay, so this is what we have done today. We've talked about correlation analysis, and we've talked about the different steps to um, perform correlation analysis in Excel. We've talked about how to draw a scatter diagram. We've talked about how to calculate the correlation coefficient, and we've talked about how to find the least squares regression line, both the equation and the actual line itself, drawing the line. Now, if you have any questions, please do not hesitate to contact us at the Math Center or the Student Learning Center directly through the Dropbox through our website. You can email any of us, Michael Shee or myself, Denise Williams, directly, and we will also love to hear from you and answer any questions you may have. In addition, there are some YouTube videos that are available about performing correlation analysis using the data analysis toolpack. Be forewarned that they might be a little bit more uh, complicated than you need, but it's still a good resource to have. Again, contact us at the Student Learning Center or the Math Center for any additional assistance at any time. We would love to hear from you, and we're here to help you. So that's it for today's webinar. Thank you for watching, and look forward to seeing you again next week. Bye.